Assalamualaikum. My name is Aliz. My partner Thitthima and I from 3BITI will present our image processing final project, the rice grain counter. Rice is a staple food for Malaysia. It is obtained from paddy plant. Crop yields largely depend on the number of grains per spike and the 1,000 grain weight. Therefore, 1,000 grain weight is considered an important parameter for the effective evaluation of cultivation measures and variety breeding. It is a measurement indicator frequently used in crop research. Thus, counting is the first step in the measurement of 1,000 grain weight. For this project, the problem statement are first, manual counting is laborious and time-consuming. Human eyes may be tired and thus cause errors. Secondly, how to identify the standard rice grain. And lastly, how to differentiate the defective rice grain from the faultless rice grain. Next, the objective for the project are to count individual rice grains, to identify the total number of rice grain that fits the standard in a certain quantity, and to find the defective rice grain size. To successfully complete this project, the following image processing concepts are used, including intensity transformation, contrast, segmentation, edge detection, binarized image, and lastly, color space conversion. Next, the area of the labeled grain is found. If the area is more than 100, the total value adds by 1. If not, it does not add any value. Next, if the area is also more than 500 or less than 8,000, the standard is added by 1, and if not, it does not add any value. And if there are more grains, the loop will continue. Then the total number of rice grain is printed out. The total number of rice grain that fits the standard is also printed out. The histogram of size of grain is also generated. And the system ends here.
Hi, my name is Thitthima and I will explain about the coding and do the system demonstration. Now, I'm going to explain about the coding. First, we close and clear all the workspace. After that, we read the image that we will use in this project. And then we convert the image to grayscale. And then we will print the histogram graph to check the threshold. After that, we will adjust the contrast of the image to differentiate the background and the rice grain. And then we convert the image to binary and we identify the object in the image. And then we change the image to RGB to check whether the system can differentiate the background and the rice grain correctly or not. After that, we label each rice grain with number and print out the label image. And then we find the area of each rice grain and then we calculate total number of rice grain in this picture. And then we calculate the total number of rice grain that fits the standard size for this type of rice grain. And then we print out the RGB image and the histogram graph of number of the rice grain versus size of rice grain. And lastly, we print out the total number of rice grain and the total number of the rice grain that fit the standard size of this type of rice grain. Based on the image that we use, so this is the result. First, we can see here the total number of rice grain in the picture is 50. And then the total number of the rice grain that fits the standard size in that picture is 40. And here we can see that the image after we increase the contrast. And then this is the image that we change to RGB to differentiate the background and the rice grain. And lastly, here is the label rice grain image where we label it with number. Based on the output generated, we can see here there are two graphs was generated. Firstly, the histogram graph of the grayscale image. We can see here that the graph is biased to the left side, which means the image that we use in this project has more dark color compared to bright color. This graph is used to determine the threshold. This threshold is used for segmentation to separate the background and the rice grain image. The second graph is the graph of distribution number of rice grain based on its size. We can see here that the rice grain size between 600 until 700 has the maximum number of rice grain. Based on our project, we have found several advantages and disadvantages. The first advantage that we found in our project is our project can detect more than one type of rice grain. The second advantage of our project is our project can differentiate defective rice grain from the faultless rice grain. For the disadvantages, our project is unable to detect rice grain if it's too close to another.
Lastly, during the development of this project, there are some constraints that were found. First, the coding needs to be altered according to the different type of image file. And next, the limited access to various kinds of rice grains. That is all for our presentation. Thank you for watching.